Hi statistics students. Here is chapter 9 on hypothesis testing, and we'll be testing hypotheses in chapter 10 as well. Chapter 9 is about testing with one sample, and chapter 10 is about testing with two samples. So the title of chapter 9 is Hypothesis Testing with One Sample, a Single Mean, and a Single Proportion. Once you sample, you can calculate the sample mean from your data if the data is quantitative, or the proportion, like 90% of people are right-handed, if the data is qualitative, like what hand do you write with. So once you have the sample mean or the sample proportion, where do you go from there? In chapter 8, we looked at building confidence intervals. And so I have a little example here of a rabbit making a statement of a confidence interval. Once you have a sample mean of age 21, then you construct the confidence interval that could be between 19 and 23. So that's giving you a range of possibilities for what this actual population mean is based on the sample mean. The hypothesis testing would look like this. The rabbit says they claim that the population mean student age is 21, but I got a sample mean of 24.5. That's a little bit high. Should I reject their claim? That's what hypothesis testing is about. If you got a sample mean student age of 22, you might say, well, that's just a little bit of variability in sampling. No big deal. I still believe their hypothesis that the mean student age is 21. But the higher your sample mean is, at some point, you're just gonna say, I don't believe you. And that's really what this chapter is about. What is the threshold where we decide, you know what, I don't believe your hypothesis anymore? And we have a very mathematical way to do that. So hypothesis testing, the statisticians make inferences about populations based on the samples. Confidence intervals estimate the population mean or the population proportion, mu or p. Another statistical inference is to evaluate a claim, like that claim that average student age is 21. So the 5 steps of our process are to set up the two hypotheses, do your sampling, decide if you're going to use the Z or T distribution, and the rules for which distribution to use are the same as they were in chapter 8. We only use T when sigma is unknown. Let's see, analyze the sample data, decide if you're going to reject or fail to reject the null hypothesis. And I know fail to reject is a little bit weird. Why don't we just say reject or accept? We say fail to reject. Accepting it's a little convoluted why we don't say that, but we say you're going to reject or there wasn't enough evidence to make us reject, so we didn't reject it. And then we make our conclusion after that. Null and alternate hypotheses. So how do we write these hypotheses? Both are statements about the parameter, so they're going to either be about mu or about p, not x bar and not p hat, okay? These are the ones that we don't know about. These are the ones that are generally unknown to us. And so that's what we're hypothesizing about. Once we do our sampling, we know our x bar and we know our p hat, so we're not hypothesizing about that. The alternative hypothesis, what we conclude when we reject H0. Yeah, so we have this default hypothesis that we start with. H0 is the default. And then the alternate is like, if there's enough evidence, if we're really pushed to it, we will flip to the alternate hypothesis when we reject H0. So traditionally in this class, the null hypothesis has the format of, let's just say, mu equals 21. And then the alternate hypothesis could have a number of forms. It could be mu is not equal to 21, or it could be mu is less than 21, or it could be that mu is greater than 21. But again, we start off believing the claim. We start off with the null hypothesis that says the population mean student age is 21. And then I'll lead you through a process where we determine whether we are going to reject the null hypothesis or not. We never actually get to prove the null hypothesis. We just either reject it or fail to reject it. So here's 3 examples. We wanted to see if more than 25% of students get an A in the class. Our null hypothesis and our alternate hypothesis are both about, are they about mu or about p? Well, this is talking about a percentage. So that tells me that our hypotheses are about the population proportion. The null hypothesis says P is equal to 0.25. And the alternate hypothesis is P is greater than 0.25. So again, the null is always the statement of equality, and the alternate is either greater than, less than, or just not equal to. Okay, down here, null hypothesis. We want to test whether the mean height, mean. So this is going to be about mu. The mean height of 8th graders is 66 inches. So the null hypothesis is mu equals 66. This statement doesn't indicate a direction. It didn't say taller than or shorter than. So when I go to my alternate, I just say not equal to 66. That's my alternate hypothesis. We want to test if it takes less than 45 minutes to teach a lesson plan. So this one, I think you can probably do it yourself. If you want, take a minute to try. Is this about mu or is this about p? Okay, so those are the alternate, null and alternate hypotheses for these 3 stories. Okay, what distribution do we need for this hypothesis testing? When testing a single population mean, so if we're testing for mu, then the distribution, the distribution for the test is the distribution of x bar, and this is what we learned in chapter 7. This is the distribution of the sample means. The sample means are distributed normally with the same mean as x, and the standard deviation is sigma over root n. Now, if we get ourselves into a situation where we do not know the sigma for the underlying distribution, then we go to our plan B, which is to use the t distribution. So the population parameter is mu. The estimated value or point estimate for mu is x bar, the sample mean. And then we can use the z-test or the t-test. And again, these are going to be in our calculator under stat tests, and I'll show you how to do that shortly. If you are testing a single population proportion, then we are talking about p. And p represents the percent of the population. Like 90% of people are right-handed. The estimated value for p is p hat. So x bar estimates mu, p hat estimates p. P hat is x over n, where x is the number of successes and n is the sample size, and we use one prop z-test. So these are the three things we're going to be using in our calculator for hypothesis testing. Now, if you think about the normal distribution, the distribution of x bar, this is what you learned in chapter 7, then the x bars, their middle is here at mu. We would expect that the sample means are pretty close to the population means, but they might be a little bit below or a little bit above or a little lower or a little higher, but they're really unlikely to get too far away from the population mean. So what happens is that when we start getting an x bar over here, we get suspicious. We're like, that's too far away from mu. So over here is when we get suspicious. I am not spelling suspicious correctly. Okay, so if we're far enough away, we reject the null hypothesis. And I'm going to start a new video for the next slide.